In this video, we will explore the creation of a design tool called integration, or the relationships of elements. In nature, there's a complex web of relationships. We can copy this in our designs by creating useful connections between the components. David Holmgren summarized this as integrating rather than segregating. In this video, we will analyze some components, determine the outputs of those components, and how the outputs can be useful inputs for another component. And I'll show you some of the ways to make those connections. The end goal is to create opportunities within your permaculture design for the components to have their needs met by another component. The design creates a web of functional connections. At the end of this video, you will be shown a method of connecting the elements with the use of cards. This approach makes the creation of functional links between elements easier, almost as simple as playing dominos. In most of the permaculture textbooks that you read, they call the components of the design an element. There are many elements that you could have in a permaculture design, but it's not the number of things in the system that makes it a rich system. It's the functional connections between those elements. So how do we build a web of functional relationships? We strengthen the beneficial relationships and we reduce the harmful. We connect the elements so that the output, the waste from one component, goes into the other as an input, a food source, or something that they need. We need to have a good look at each element to find out what it needs and what it produces. And it will often have some unique intrinsic characteristics. The needs are often fuel, food, warmth, and shelter, and any unused inputs can be wasted. At the other end, the products or the outputs are usually manures or fallen leaves, but they can also be warmth, eggs, honey, fruits, or even bird song. For the intrinsic characteristics, that's where we have a look at what makes it different to similar elements. For instance, snakes and lizards are similar, but they have very different levels of risk. What does an element have? The bee needs water and pollen, and a hive, and protection from predators, and companions. And it produces its own temperature regulation, honeycomb, honey, and more bees. But on the intrinsic characteristics, bees vary. They vary in size and colour, the levels of aggression, the productivity and hardiness. So we know some of the needs of the bees, and we know some of the products of the bees, the outputs, and we understand the intrinsic characteristics of bees, especially the difference between domesticated bees and native bees. The beehive itself is an element because it needs maintenance and protection from being blown over by the wind or knocked over by tractors or people, and we need to level the beehive. In this example here at the farm in Byron Bay, they have electric fencing taped around it so that people or deer or other types of predators don't disturb the beehives. What does the beehive produce? It produces mostly shelter to the bees, but it can produce water catchment. And the intrinsic characteristics here show just the difference in colour because they're all the same type of hive, but there are many different hives that you can find. In ecology, they talk about 6 types of relationships. We can have a win-win, where we both benefit, or we can have harmful competition, where we both lose. And there are times where something will benefit and the other thing will not notice the difference. In the win-win, it's mutualism. In the harm, it's competition. When something benefits and the other has no effect, that can be called commensalism. When something benefits and the other is harmed, that's a parasitism. But when nothing happens because we're not really affecting one another, that's neutralism. And then one has no effect, was completely oblivious, but harms the other, that's amensalism. I can think of a win-win where we have a mutual exchange of ideas. And I can think of a harm where we go into battle and nothing changes. Now let's have a look at how we can analyze an element. In this example of the bee, we can look at the needs of the bee. The bee needs water and it needs nutrients, gets that from the pollen, and it needs light, it needs some warmth, it needs boundaries and protection, and it needs support. It does need some expertise from the handler. It does cost a little bit to set up, but it's portable and it has high value because of what it provides. Most people will think instantly, oh, the most important product from a bee is the honey, but it's not. Economically, the most important product of the bee is pollination. And a dead bee and the honey is nutrient, and for some people that's their income. So we see the needs could come from ponds and creeks and a bird bath for the water. For the pollen, it can get it from flower gardens or forest. And the warmth can come from warm breezes or the sun on the rocks behind the hive. We can see where the products go. The pollination can benefit the crops and nut and fruit trees. The honey and honeycomb go to people. The noise that the bees make can deter vandals. And the bees can make more bees, so we can have more hives. So this is how we connect the two. We've connected the bees to their hive. We've created a beneficial connection. And we can connect more elements. We could put a fountain near the hive so that the bees can get their water. Let's look at the needs and provisions from the worm. A compost worm needs water and nutrients, food scraps or prunings from the garden. It needs some shade and it needs nice temperature, the Goldilocks zone. It needs some boundaries so that they don't stray. It needs protection from predators like birds, anteaters or echidnas. It needs some support. It needs some bedding and it needs access so that it can find one another and find the food. It provides nutrients, really rich nutrients in the form of wee and manure. Some people use it as an income or energy source, and it can be a food source for the chickens. So down the bottom here, we say that the needs could come from scraps and weeds, and the functions can go to plants and chickens. Over time, you will use the cards and lay them out like a set of dominos. You can see how things connect, and this actually is a good visual, a good way to map out where the elements can go. There are ways to connect things that are not always in a line. You could put things over and under and beside and around, like the bee in the beehive and the worm in the worm farm. This system could be used for things that you don't want, elements that you don't want in the system. In our case, we have a weed called Madeira vine that goes up into the canopy of the forest and collapses the trees. It's an element that we don't encourage. So we have to understand, we can analyze that weed. We see it needs water, nutrients, light, protection and support. It provides some nutrients and a lot of shade, and it's very portable. So what we need to do is disconnect the elements that it needs. We disconnect water and we remove the support. Our chickens are very good at disturbing this weed, and they've learnt to eat it. We feed it to them when they're chicks. Here's another example of an unwanted element. Let's say you've got mold in the bathroom. What are the needs of the mold? It needs high humidity. It needs some nutrients, usually gets that from dust. A leather jacket can go moldy, but it's actually the dust on the leather jacket that's gone moldy. It needs shade. It needs warmth, and it needs some protection from harsh winds. What does it provide? Well, I guess it provides nutrients, and it's an essential part of a decomposition process. So its needs come from dark, humid, unventilated rooms, and it does provide a function to the garden. Once we've identified where that humidity is coming from, such as a leaky shower or water underneath the house, or perhaps you're using an unflued gas heater, then we need to remove the water source and maybe lighten up the space by installing a bigger window and improve the ventilation with a fan or by opening the window. In warmer climates, we can simply install an outdoor bathroom and accept mold as part of the system. So again, we've disconnected the elements. We try to remove the humidity, we remove the dark by making more natural light, and then the mold has less of what it needs. Now it's time to make your own set of analysis cards for your key elements. Make a card that looks something like this, with the needs on one side and the provisions on the other, and then you can start to build a rich web showing the relationships of the elements.